Physics part 417. Well, there are two stages. Stage number one, the background intensity must be removed. This background is equal to sum of the detector readings for any one position. In this case, the sum is 20. The background is deducted from each pixel as shown in the figure. Stage 2. Allowance must now be made for the fact that more than one view was made of the section. In this example, there were four sets of readings, and consequently, each pixel reading is divided by 3. The final result is shown in the figure, and note this is the same as in the figure. Once the pattern of pixel for one section has been obtained, the CT scanner is moved relative to the object so that the next neighboring section is analyzed. The procedure is repeated until the whole of the object to be analyzed has been scanned. The analysis above is a very simple example. In practice, the image of each section is built up from a large number of units or voxels. The larger the number of voxels, the better the definition. This is similar in principle to the digital camera. The use of a large number of voxels implies that measurements must be made from a large number of different angles. The storage of the data for each angle and its construction into a final image on a screen requires a powerful computer reconstruction. The intensity, well, the screen requires a powerful computer. The reconstruction of the intensity in each voxel will involve more than 1 million separate computations. I beg your pardon, please. The storage of the data for each angle and its construction into a final image on a screen requires a powerful computer. The reconstruction of the intensity in each voxel will involve more than 1 million separate computations. All the data for all these sections is stored in the computer memory so that a three-dimensional image of the whole object is formed. This enables sections of the image to be viewed from many different angles. Finally, the computer enables the brightness and contrast of the image to be varied so that the optimum image may be obtained. We've got an example for you. Compare the image produced during an X-ray investigation and that produced in CT scanning. X-ray image is a two-dimensional projection into a flat screen of three-dimensional object. A CT scan is a three-dimensional image. The computer in which the data for the image is stored enables different sections at different angles to be viewed. Now it's your turn. Number one, the principles of CT scanning have been understood for some time. However, scanners could not be developed until large, powerful computers were made available. By reference to the image produced in a CT scan, suggest why such a computer is necessary. Number two, a simple object consists of four voxels. The object is scanned from four different directions, each at 45 degrees to the next. The detector measurement for each individual voxel are summed and a result is shown in the figure. The total of the readings of the detectors in any one position is 22. Determine the pattern of the pixels in the voxels. We've got section summary. Number one, remote sensing enables. I would like to put the summary in my next video because it can make a sense in a single video as we have reached at the last stage of this video and we can't give the further details here.